Welcome, curious minds, to another deep dive. Today, we're pulling back the curtain on a surprisingly dynamic corner of medical technology,
That's right.
one that's literally reshaping how we treat, well, the most complex organ in the human body, the brain.
Indeed.
Get ready to explore a market whose growth might just astound you.
It's a fascinating area.
It really is. So, our deep dive today is all about the global neurology endoscope market.
Hmm.
We're talking about those, incredibly precise instruments that allow surgeons to navigate the brain with minimal invasiveness, offering critical solutions for really complex conditions.
Exactly. Understanding this landscape is, well, it's key to grasping where cutting-edge neurological medicine is truly headed.
And to guide us through this intricate market, we've extracted the most vital insights from detailed analysis and forecasts,
Yes, this comes from cognitive market research. Our mission really is to distill the core knowledge from this data.
giving you a clear, comprehensive picture of where this specialized market stands globally and, the significant trajectory it's on.
Precisely.
Okay, let's unpack this with the big picture right away. The global market for neurology endoscopes generated, around $143 million in revenue back in 2021.
That's the figure.
Mm-hmm.
And the trajectory. Well, it's projected to grow substantially.
How substantially?
We're looking at hitting over $183 million by 2025, and then it really takes off, soaring to more than $304 million by 2033.
Wow, that's more than double in, just over a decade? What's behind such explosive growth in a specialized field like this?
Yeah, that kind of sustained acceleration is quite striking. This isn't just a fleeting trend. The data shows a robust compound annual growth rate, or HEGR, of nearly 6.5%.
Almost 6.5% year on year.
Exactly. And the primary drivers are, well, multifaceted. There's a big global push towards minimally invasive surgical procedures
Right.
because they lead to reduced patient recovery times, fewer complications, and often, lower overall healthcare costs.
Makes sense.
And you couple that with an aging global population and the rising prevalence of neurological disorders, things like hydrocephalus, brain tumors, intracranial bleeding.
So the need is growing.
The demand for these precise diagnostic and therapeutic tools is escalating significantly. Yes.
That makes perfect sense. So it's not just about more money being spent, but also the evolution of surgical techniques and an increasing medical need.
Precisely.
Now, for listeners who might be picturing just a standard camera, can you explain what makes a neurology endoscope uniquely suited for this delicate work inside the brain?
Sure.
What are its key components, and how does it really revolutionize neurosurgery compared to, say, older, more invasive methods?
Absolutely. Unlike traditional open cranial surgery, a neuroendoscope is, well, it's a thin tube. It can be flexible or sometimes rigid,
Okay.
and it's equipped with a high-resolution camera, a powerful light source, and often channels for tiny surgical instruments like forceps or lasers.
So tools can go through it too.
Exactly.
Yeah.
This lets surgeons access deep brain regions through a very small incision, sometimes just a few millimeters,
Tiny.
which minimizes trauma, blood loss, and greatly reduces recovery time for the patient. It's a game changer for a whole range of procedures.
Like what specifically?
Well, precise tumor biopsies, draining fluid buildup in hydrocephalus, treating aneurysms, anywhere. Precision and minimal disruption to surrounding brain tissue are absolutely paramount.
All right.
And the advancements in miniaturization and imaging clarity are just making these procedures accessible to more patients globally.
That's a fantastic overview, really highlights the ingenuity. Okay, now let's zoom in on the where of this market. North America, perhaps unsurprisingly, holds a commanding lead.
It does.
Its market clocked in at about $57 million in 2021, projected to reach nearly $73 million by 2025, and then a remarkable $117 million by 2033.
Significant numbers.
Very. What unique factors are allowing North America to maintain such a dominant position? And, what lessons might other regions draw from its success?
That's a critical point. North America's dominance, it largely stems from its advanced healthcare infrastructure, high levels of healthcare spending, and significant investment in R&D, especially in the medical device sector.
Okay.
The United States is the primary driver, no question. It accounts for the vast majority of that regional market.
What kind of numbers are we talking for the U.S.?
Over $46 million in 2021 and projected to hit more than $93 million by 2033.
Wow. Okay.
Canada and Mexico also show steady growth. Canada's looking at nearing $14 million and Mexico over $10 million by 2033.
So what's the key takeaway? Early adoption.
Early adoption of advanced medical technologies, yes, and established reimbursement policies for these procedures. Those are key contributors to the region's continued leadership.
Right, reimbursement is always a big factor.
Yeah.
Okay, having seen North America's lead, one might expect Europe to follow a similar path, given its advanced systems. Is that what we see? Or are there maybe unique market dynamics as we guide listeners across the Atlantic? Europe reached over $41 million in 2021, estimated near $53 million by 2025, and projected close to $85 million in 2033.
It's an interesting comparison.
Yeah.
Europe shows consistent, strong growth, definitely.
Hmm.
But its market is more fragmented.
How so?
Germany, France, and the UK are certainly leading the charge.
Yeah.
Germany, for instance, is looking at nearly doubling its market share over the projected period, reaching over $12 million by 2033.
Okay.
But what's particularly intriguing is the accelerated growth we see in countries like, say, Russia and Italy.
Oh, interesting.
Yeah, it indicates expanding adoption beyond just Western Europe's,
Right.
established healthcare systems.
It's broadening out.
Exactly. And the rest of Europe segment is also a significant contributor. It's projected to grow from around $10 million in 2021 to over $23 million by 2033. That reflects a really widespread increase in capability and demand right across the continent.
Fascinating. Okay, now, here's where it gets really interesting, I think, as we turn our attention to Asia Pacific, a region showing incredibly robust expansion.
Absolutely, the growth rates there are notable.
Over $26 million generated in 2021, expected to grow to nearly $35 million by 2025, and projected to hit over $63 million by 2033.
Mm-hmm.
But when we look at countries like China and India, huge populations, diverse healthcare systems, are there specific market access challenges or unique adoption patterns we should be aware of beyond just the raw numbers?
That's a critical distinction to make, yes. While the overall numbers are impressive, the drivers within Asia-Pacific are quite dynamic.
Okay.
China is leading the region, projected to reach nearly $18 million by 2033. That's largely driven by, increasing hospital budgets and rapid tech adoption, especially in major urban centers.
And India, you mentioned strong growth there.
India really stands out. It's projected to hit over $9.5 million by 2033. That indicates expanding access not just in the top cities, but in Tier 2 cities too, plus a burgeoning medical tourism sector.
Right, medical tourism is big there.
It is. Japan and South Korea also contribute significantly. The challenge often lies in scaling up the specialized surgical training and infrastructure needed to meet this demand across such a large and diverse region.
So the demand is there, but building capacity is key.
Exactly. But the commitment to upgrading healthcare facilities is definitely evident.
Okay. Shifting our focus now to South America. The market there stood at nearly $10 million in 2021, projected to reach over $13 million in 2025, and then nearly $24 million by 2033.
Steady growth there as well.
What can we say about the healthcare development in this region? What specific needs are driving this market's growth?
Well, a key insight here is the significant contribution from Brazil. It led with about $3 million in 2021 and is projected to reach over $7 million by 2033.
So Brazil is the main player.
It's the largest, yes. But Argentina and Colombia also show notable growth. The overall growth in South America seems largely fueled by increasing investment in medical infrastructure, plus a rising awareness of advanced surgical techniques and, like elsewhere, the growing prevalence of neurological conditions needing these precise interventions.
And the rest of South America.
That segment also demonstrates substantial expansion. It's expected to nearly triple its market size to over $10 million by 2033. It reflects a broader regional push for, modern medical solutions.
Good to see. All right, bringing you now to the Middle East, a market valued at just over $5 million in 2021, projected to reach over $6 million in 2025, and nearly $9 million by 2033. Given the unique economic and geopolitical landscape here, what factors are influencing the adoption of these high-tech medical devices?
Well, putting this in context, Saudi Arabia clearly held the largest share in the region. It's projected to reach over $3 million by 2033.
Okay.
Turkey and the UAE are also significant players. This region's growth is often linked to substantial government investments in healthcare infrastructure.
Right, often driven by oil wealth.
Often, yes. And there's a strategic focus on developing world-class medical facilities. That caters to both local populations and, again, medical tourism.
Another hub for that.
Potentially, yes. The commitment to acquiring advanced medical technologies, including these neurology endoscopes, it's a clear priority to elevate healthcare standards there.
Makes sense. And finally, concluding our regional analysis, let's look at Africa. Market size nearly $3 million in 2021, projected to reach almost $4 million in 2025, and nearly $6 million by 2033.
A smaller base, but growing.
It seems like a nascent market, yeah. What can we learn about the distribution of growth and the opportunities present there?
It's true, it's a smaller market compared to others, but it's critically important to recognize its accelerating growth.
Hmm.
It highlights an emerging demand.
Okay.
South Africa leads the continent, growing to almost $2 million by 2033. Nigeria follows, projected to reach over $1.2 million.
And the rest of the continent?
The rest of Africa's segment also shows significant potential. It's increasing from around $1.2 million to over $2.5 million by 2033.
So doubling roughly.
Yeah. This growth, while from a smaller base, indicates a crucial expansion of healthcare access and improving medical capabilities in key African nations. It's about bringing advanced neurological care to more communities.
That's really important progress. So we've toured the globe. What does this all mean for the overall market and its broader implications?
Well, stepping back to consider the wider implications, what truly stands out is the consistent, widespread global growth.
Right.
While North America clearly holds a dominant position today, and Europe is a strong second, we're witnessing truly significant and accelerating expansion in Asia-Pacific.
Definitely a key growth story there.
And indeed, robust growth across all continents, even from smaller bases. This underscores that this specialized medical device sector is undergoing substantial, widespread expansion.
So it's not just a developed world phenomenon.
Not anymore. It reflects an increasing global need and capability for advanced, minimally invasive neurological procedures. It really speaks to a universal trend towards more precise and patient-friendly interventions for complex brain health issues.
That leads to a final thought then. Considering this consistent and really significant growth we've discussed, what do you think this implies for the accessibility of these advanced neurological surgical procedures globally?
That's the big question, isn't it?
And how might it reshape the future of brain health innovation in different parts of the world? Something for you, our listeners, to consider.
Food for thought.
Thank you for joining us on this fascinating deep dive into the global neurology endoscope market. We encourage you to continue exploring the amazing intersections of technology, healthcare, and global markets. Until next time. You know that feeling? When you stumble onto something really specialized, almost hidden, but it's actually making a huge impact, it's pretty fascinating. And today, we're doing a deep dive into exactly that kind of area, a critical piece of healthcare tech. We're focusing on the global neurology endoscope market today, and our goal really is to pull out the key insights from all the material we've gathered. We want to give you a solid understanding of this pretty complex field, but without, drowning you in data. The idea is you'll get a real sense of how this cutting-edge technology is, well, quite literally changing brain surgery, how it's leading to better outcomes for patients, and honestly, pushing the boundaries of what medicine can even do.
It's pretty amazing how fast this market is actually growing. And when you start digging into why, two big drivers really pop out. I'd say the most powerful one, the biggest force, is the huge shift across the whole industry toward minimally invasive surgery.
Right. Less invasive.
Exactly. So instead of the traditional open surgeries where they remove a piece of the skull, we're seeing this definite move towards techniques that are much less disruptive.
And the benefits must be pretty clear.
Oh, absolutely. For
Yeah.
patients, for surgeons, it's compelling. You're looking at smaller incisions, way less blood loss, shorter stays in the hospital, and quicker recovery times. These clinical advantages, they're directly fueling the demand for these neurology endoscopes everywhere.
Okay, so that's the procedural shift. What else is driving it?
Well, if you zoom out a little, another major factor is just the rising number of people diagnosed with specific neurological conditions. Things like hydrocephalus, that's the fluid buildup in the brain, or pituitary tumors right at the base of the brain.
Yeah.
As we get better at diagnosing these, especially maybe with an aging population too, the need for specific endoscopic procedures goes up. Techniques like endoscopic third ventriculostomy, ETV, or transfenoidal surgeries for those pituitary tumors, they aren't experimental anymore. They're basically standard care now, affecting younger people, older people. It really drives demand for the tools.
So you've got the push for less invasive options and more conditions being treated this way. But how much of this growth comes from, just better tech? Things we couldn't do before, especially what surgeons can actually see, What's the impact been from, say, breakthroughs in visualization?
Oh, that's a huge piece of the puzzle.
Yeah.
It really is. The evolution there has been incredible. We've gone from standard definition, which seems ancient now, to high def, then 4K, and now even 3D imaging systems.
Wow.
And what that translates to for the surgeon is just exceptional clarity and, crucially, depth perception.
Yeah.
Imagine doing a really delicate procedure deep in the brain with that kind of visual detail, that true stereoscopic vision from 3D.
Yeah, I can see how that would make a difference.
It massively boosts surgical precision. And safety, of course, especially when you're working in those incredibly complex, tight spaces in the brain.
It really sounds like brain surgery is undergoing a bit of a revolution. But, with any tech like this, especially cutting-edge stuff, there have got to be challenges, right? Hurdles. What are the main roadblocks slowing down wider adoption of these advancements?
You're absolutely right. Yeah, despite all the obvious benefits, there are significant hurdles. I'd say the first big one is simply the cost, the high capital cost of the systems.
Okay, what does that actually involve? Like, what are we talking about cost-wise?
Well, setting up a complete neuroendoscopy suite it's not trivial. You need the camera system itself, the light source, the high-res monitors, all the recording equipment, and then the scopes themselves. These are delicate, specialized instruments. It adds up to a really substantial financial investment.
Right. So that could be tough for some hospitals.
Definitely. Especially smaller hospitals or maybe facilities in developing regions, that upfront cost can be a major barrier.
Makes sense. What else?
Well, beyond the money, there's the pretty steep learning curve for the surgeons.
It's not just plug and play.
Not at all. Endoscopic neurosurgery, it demands a completely different skill set compared to traditional open surgery. Surgeons have to get really good at operating these long, thin instruments while looking at a 2D or 3D screen, not directly at the tissue.
That sounds disorienting.
It can be at first. It's a very different hand-eye coordination challenge. It takes dedicated, specialized training, often, fellowship-level expertise. So getting it widely adopted is more complex than just buying the machine. It takes time and significant training resources.
You mentioned learning to operate by looking at a screen. Are there other, maybe inherent technical limitations they still face with the tools themselves?
Yeah, there are a couple of key things. One is often poor tactile feedback.
Meaning they can't really feel the tissue?
Exactly. In open surgery, you get that direct feel. With an endoscope, you're relying almost entirely on the visual information. That's a big shift. And another challenge is something called limited instrument triangulation.
Triangulation?
Yeah, think about trying to, say, tie a knot using long tweezers while looking through a tiny hole.
Okay, tricky.
It's hard to get the instruments angled correctly against each other to perform delicate tasks like suturing inside a very confined space. It takes a lot of skill to overcome that.
Okay, so we have cost, the learning curve, and some tricky technical aspects like feedback and movement. But it's not all roadblocks. Innovation must be tackling these issues, right? What are the exciting trends? What's shaping the future here?
Oh, definitely. And that's where it gets really interesting. One big trend is the increasing use of those 3D endoscopic systems we mentioned.
Right, the better depth perception.
Precisely. They provide that true stereoscopic vision, that sense of depth, which gives surgeons much better control during these really delicate procedures. You're seeing 3D becoming pretty much standard in advanced neurosurgery centers because it helps bridge that gap, that spatial understanding issue.
And is that linking up with other technologies too?
Yes, exactly. That ties into another really strong trend, integrating endoscopy with things like neuronavigation and augmented reality.
Okay, explain that. How does that work?
So imagine the surgeon is looking at the live endoscopic view on the screen, but overlaid on that view in real time is data from the patient's pre-op MRI or CT scans, like a GPS for the brain.
Wow.
And then augmented reality can add even more, maybe highlighting critical nerves or blood vessels, or showing the planned trajectory for the instrument right there on the screen.
So it's giving them layers of information they didn't have before.
Exactly. It massively enhances their situational awareness and helps with decision-making during the surgery. It makes things safer, more precise. It's really powerful stuff.
That's incredible. And what about the endoscopes themselves? Are the actual tools getting brand new?
Absolutely. That's the final piece, maybe. We're seeing really exciting developments and making the scope smaller and more versatile.
Smaller how?
Like ultra-thin neuroendoscopes. These let surgeons access parts of the brain with even less invasion, making procedures even more minimally invasive.
And versatile. You mean they can do more?
Well, partly that, but also versatile in terms of where they can see. We now have a much wider range of angled scopes.
Yeah.
Think lenses angled at 30 degrees, 45 degrees, even 70 degrees.
Ah, so they can look around corners,
That's
essentially.
a great way to put it. Yeah, they allow surgeons to visualize anatomical structures that were previously hidden just out of the line of sight with a straight scope. It opens up new treatment possibilities.
Okay, so putting this all together, what's the core takeaway here for our listeners? What does this deep dive really tell us? It feels like it's more than just, brain surgery is getting better. There's something fundamental changing.
I think that's right. The global neurology endoscope market, it's evolving incredibly fast. You've got the clinical need pushing it, amazing imaging innovation pulling it, and just this urgent drive for safer, faster, less invasive ways to treat really serious conditions. It's a confluence of factors.
So understanding these trends, it's not just academic, it shows how patient care is actively being transformed.
Precisely. It highlights how technology is really pushing the boundaries of what surgeons can achieve, making a tangible difference in people's lives. It's quite profound, actually.
So here's something maybe to think about as we wrap up. We've talked about these incredible technological leaps, right? The 3D, the AR, the tiny scopes. But we also talked about the really steep learning curve, the need for specialized training. So, given that, how might these advancements change things in the future? Not just who can do these complex surgeries, but maybe even how we think about medical expertise itself, how it's developed, how it's shared globally, something to really ponder as we watch this field continue to evolve.